This question is from GATE 2022, Mechanical Engineering Paper Set 1, question number 52. A thin-walled cylindrical pressure vessel has mean wall thickness of T and normal radius of R. The Poisson's ratio of the wall material is 1 by 3. When it was subjected to some internal pressure, its nominal perimeter in the cylindrical portion increased by 0.1% and the corresponding wall thickness became T bar. The corresponding change in the wall thickness of the cylindrical portion, that is 100 into T bar minus T by T, is %. Rounded off to 3 decimal places. Let's find out. We are being asked to calculate this percentage change in thickness, that is T bar minus T upon T into 100, which is nothing but delta T by T into 100. This is nothing but epsilon T into 100, which is strain in the thickness direction. What is given to us is nominal perimeter in the cylindrical portion has increased by 0.1%. So perimeter has increased, which denotes the increase in diameter, because perimeter is nothing but pi d, and therefore this 0.1% which is given is the hoop strain. That is nothing but delta d by d, 0.1%, which is 0.1 by 100. Now let's find out epsilon t here. So using generalized Hooke's law, we can write down the hoop strain as hoop strain will be equal to hoop stress upon E minus mu sigma L longitudinal stress upon E minus mu into sigma T upon E. This is radial stress upon E. We can take radial stress as 0, which is nothing but this. If this is the thickness shown, the radial stress is stress across the thickness, and this can be taken 0. So hoop strain is 0.1 upon 100 is equal to sigma h, hoop stress, is given by PD by 2T and longitudinal stress is PD by 4T. These values are standard values and you need to remember this. So if you substitute hoop stress here, PD by 2TE minus mu into, this is PD by 4T. So we substitute it here, minus 0. If we take PD by 4TE common, we have PD by 4TE into 2 minus mu. Let this be equation 1. Value of mu is given to us. We will substitute it later. Now we need to find out epsilon t. So using the same generalized Hooke's law, we can write down expression for epsilon t as well. Epsilon t will be equal to sigma t by E, which is 0 because sigma t is 0, minus nu into sigma h by E minus nu into sigma L by E. After substituting this value PD by 2T and PD by 4T for sigma h and sigma L respectively, we will have this as minus mu by E into PD by 2T plus PD by 4T. So this turns out to be 3 PD by 4T. So we have this as minus 3 by 4 nu into PD by TE. Now in order to find out sigma T, nu is known to us, but we do not know P, which is the internal pressure. We do not know diameter D of the cylinder, and we also don't know the thickness and E. But we can calculate this total term altogether from equation 1, because we know nu here and left hand side is already known to us. So let's do that. From equation 1 we will have, by rearranging, PD upon 4TE. Why don't we take 4 as well? So this complete term we are calculating, PD by 4TE, which will be equal to 0.1 upon 100 into 2 minus mu is given to be 1 by 3. So this turns out to be 0.1 upon 100 into 5 by 3, which is 500 by 3. So this is 0.3 by 500. This from digital calculator you will get as 6 into 10 to the power minus 4. Substituting this value here, let this be equation 2. Substituting this value of PD by 4TE in equation 2, we will have sigma T will be equal to minus 3 into nu is again 1 by 3 and this value is 6 into 10 to the power minus 4. So we get this as minus 6 into 10 to the power minus 4. This negative sign indicates decrease in the thickness because T bar is smaller than T. As perimeter is increasing, thickness is going to reduce. So epsilon T in percentage will be equal to 6 into 10 to the power minus 4 into 100, which is 0.06%. Let's go back and fill in this answer. The corresponding change in wall thickness of cylindrical portion is 0.06%. We ought to write the answer with a negative sign. Don't forget this sign here because T bar is smaller than T. To learn more about thin wall pressure vessels, you can refer to the NPTEL video Thin Wall Pressure Vessels. This is from the course Mechanics of Materials. The course is taught by Professor Sarvanan U. He is from IIT Madras. I hope this helps you clear your doubt. Thank you.